Hello, I'm Dennis Dawson. This is a quick introduction to the OpenEXI API. People love XML. The simple structure makes it easy to read. It's flexible and has many applications. XML files are portable and can be transferred from one platform to another without modification. And that's great for people. But portability is in the eye of the beholder. The truth is, to make XML easy for people to read, computers end up carrying a lot of unnecessary human baggage. Computers don't need long labels and hierarchical format to give them visual context. Computers can process a stream of information with no context at all. We can reduce the burden on our computer coworkers by sending only the most essential data. When human-readable elements are replaced with concise encoding, files are substantially reduced in size. They can pass from one computer to the next at greater speed, process more quickly, and be restored with no loss of logical content. EXI, the Efficient XML Interchange Standard, is a W3C recommendation for enhancing the communication of XML data between computer systems. It provides a more concise markup strategy for describing a document structure. It describes a method for grouping information into channels that pack the most possible values into the smallest number of bits. These efficient files are then compressed using the deflate standard to make them as small as possible. All of this is accomplished without a risk of data loss. All logical content is transferred, regardless of the configuration options you select. OpenEXI is an API that TXRs XML to EXI PDQ, A-OK? In other words, OpenEXI is an open-source Java application programming interface that provides utilities you can use to transfer extended markup language files to efficient XML interchange format and back again very quickly with no risk of data loss. If you regularly transfer large XML files between machines, or you have devices that have low memory or bandwidth, OpenEXI can substantially enhance your system's performance. OpenEXI can convert any XML file to EXI format using the transmogrifier class. If no schema information is available, the transmogrifier constructs and records the structure of the file as it's converted. We can demonstrate this with a small XML file that describes a notebook. As the SAX parser reads the file, each of the elements and attributes is handled as a separate event. By default, non-essential information is not included in the transformed file. The initial processing instruction is replaced with a start document or SD marker. But even then, the SD marker is not stored in the final file. When decoded, OpenEXI assumes that a new file stream starts with an SD event and ends with an ED event for end document. Every new element is replaced with an SE or start element event. The first time it is used, the name string is stored with it. After that, the name is inferred. Attribute and character events store the content data. After every element, we have an EE or end element event. The EE events are never named. It can be assumed that each one closes the current nested SE event. Removing the labels from the start and end elements in the file is just the starting point for reducing the file size, but it represents a significant savings in and of itself. Another reason that content can be stored so economically is EXI's use of a string table. When OpenEXI encounters a unique string during processing, the string is added to the output stream, but also added to a string table. The next time the string value appears in the file, OpenEXI marks a reference to the original value in the string table rather than storing the string a second time. When there are many repeated values in a data set, this can be a huge saving. So here's an XML file that lists some of my favorite things. It turns out that my favorite weapon is a bow. The bow string is added to the output stream, and it becomes the first entry in the string table. My favorite decoration also happens to be a bow. This time, a reference to string 1 is added to the output stream, rather than the string itself. Every element that uses the characters BOW can use the reference rather than store a new string. When the processing is finished, the string table is simply discarded. On the receiving end, the string table is reconstructed in the same order. The first occurrence of each string is added to the table as it is encountered. The values are always present before the tokens that reference them, and the original logical content is restored. There are three types of bit alignment used for EXI streams: byte-aligned, pre-compress, and bit-packed. Each represents a further shift away from human-burdened XML to more efficient XML interchange files. Byte-aligned files are the most human-readable productions from OpenEXI. These files are useful for troubleshooting because the information is encoded with normal byte boundaries intact, and you can still see some of the text in context. Token characters appear where the values are taken from the string table. You can see that using the string table, OpenEXI has already substantially reduced the size of the file. Byte-aligned files are not intended for transfer because they haven't been optimized. Looking at a byte-aligned version of a file can be helpful when you want to verify the results of your EXI transformation. If a file has an associated XML schema, or XSD, the schema can speed processing by giving the parser information up front about the types of events in the file. The names of element and attribute events can be omitted from the EXI file, and when you're using the default processing, any non-compliant events are accepted and encoded right in line. The only requirement is that the XML be well formed. But if you're confident that the XML file is 100% compliant with the schema, you can use strict interpretation to encode the file. This is faster to process and results in the smallest possible file size. When using strict interpretation, any variance from the schema, such as a string value where an integer is expected, is going to throw an exception and the EXI compilation fails. This avoids production of an incomplete or corrupted file. So here's that same file again, but this time we're going to convert it using an XML schema definition. The structure information has been removed, and only the values are stored in the interchange file. For this use case, the receiver of the information should already have the schema on hand and apply it when the file is restored to XML. Pre-compression alignment shows another way that EXI optimizes storage. Human-readable XML has to maintain a hierarchical structure for the data to make it understandable. Since the computer is not concerned with visual context, it can rearrange the data in the most efficient way for storage and transfer. By putting all the like values together in channels, the information can be tightly packed, particularly with date, numeric, and Boolean values. Looking at this pre-compressed version of notebook.xml, you can see that the structure information appears first. Next are the values for the attributes. All of the subject values are grouped together, and finally all of the detail values. When the file is decoded, the EXI reader takes a value from the top of each channel as needed to reconstruct the original file. While not an alignment in and of itself, compression is related to bit alignment because the option dictates that EXI files be arranged in channels and not bit-packed. This is how the compressed information looks when opened in a text editor. While petty mortals cannot make heads or tails of it, computers can store and transfer EXI information efficiently now that the human baggage has been removed. The use of channels, combined with the deflate standard for reducing file size, results in a very compact representation of the data. Files process and transfer up to 7 times faster with OpenEXI versus using gzip to compress a standard XML file. While optimal compression isn't necessary for all use cases, users who have a very large data set or who work with machines with limited storage or bandwidth can benefit greatly from compressing their data using OpenEXI. Bit-packed alignment is the default when transforming XML to EXI. The data are packed together in a stream without regard to byte boundaries. Sometimes this happens to result in readable text, as you can see here. That just happens if the bytes incidentally align, but most of the file is going to be unreadable to humans. There's a limit to how much benefit can be derived from file compression using the deflate algorithm. For some smaller file sizes, greater compaction can actually be achieved using the default bit-packed setting. Whitespace, comments, and other non-essential content in XML files is really there to benefit the human user. If humans are not going to use the file after conversion, there's no reason to preserve this information. Omitting comments and whitespace can substantially reduce the file size. But if your use case requires that you retain this information, the OpenEXI transmogrifier gives you the option of saving any or all of these items. If you save only the information you need, though, you will gain the greatest increase in speed and the best reduction in file size. You can see that XML with OpenEXI gives you the best of both worlds. XML information is convenient for people to work with, while EXI information is far more compact and transfers quickly for the computer. People get what they want without creating unnecessary work for their computer compatriots. If you transfer large amounts of XML data, or your XML devices have low memory or bandwidth, OpenEXI could be the solution that meets your needs.